Hi everyone, let's continue. Just now we have seen that for the dendrogram, it is simply a bottom to the top tree structure, right? Because we can just merge the samples together and together and together, and then eventually at the very top, we are merging everything into a big cluster. And of course we don't want to do that. We don't want to merge everything together, but this the y-axis will show if we want to merge everything together, and then what is the distance. Okay, so we also say if we want to do a cut at 6, and then that is the best place that we can have 3 beautiful clusters. Okay, so the next part is, since we know we can do a cut on 6, so how about we just create a hierarchical clustering and then we do the cut on 6. So we and in the SciPy, and then it is called F cluster, and then we can specify the distance. So that is the threshold at 6, and then the criterion is the distance. And after that, and we will have all the cluster labels. So now we have the cluster labels, and then we also know the 3 different type of the V's. So we have the ground truth as the 3 types of the V's. We also have the 3 cluster labels. So we can do a cross tabulation again. So for this cross tabulation, and we can see for the cluster label 1, we have 14 from one class Canadian wheat, and then we have 3 from Kama wheat. And other than that, well, we have very good results. Okay, so the next one is one of my favorite example in my lecture. What we are showing is there is a set of the performances, and then they are viewed and rated by the people in different countries. So we can have the we can well you can consider that as the taste of the different countries on the same of the performances, or the same of the shows, the same set of the shows. So as you can imagine, a different country have different culture, and they may enjoy or appreciate different types of shows differently, or quite differently, right? So if we don't talk about the shows or the performances, and if you're just talking about the music, for example, and then the different countries have different type of the preferred music. And I'm from China, and then if you consider the type of the music, and then Chinese pop music is kind of similar or close to K-pop, and then K-pop is for Korean pop music, okay? And then for the Japanese pop music, that is another very similar one. This means if someone who enjoys the K-pop or the Japanese pop music, and then for Chinese pop music, and then you may kind of like that too, okay? And then if we go down and say for Vietnam, for example, and for the Vietnamese pop music, and then I have seen some of them, and I didn't enjoy them that much. And then for the pop music in Thailand, for the Thai pop, they are okay to me as well. Okay, so that is a different type of different the taste of the music of different countries. Okay, and then let's come back to this example. If we just put everything together, that's it. Those are all the ratings of the performances, and then we have the country names. Okay, and they most of them are are European countries. Okay, and then we have a total of 43 countries, and then we have 43 of the vectors, and each of the vector is the votes of a total of 26 performances. Okay, so you can see for for the show number 1, and then it is appreciated a lot by Armenia, and then the same show is not appreciated at all by Australia. So you see there's a big difference, right? Okay, so if we want to cluster the countries based on people's test on different performances, and then we can build the clustering algorithm. So before we do that, and remember, we don't know where should we make the cut, right? So if we don't know where to make the cut, and then we don't know how many clusters there should be, what do we do? And then we can just do a dendrogram. So for the dendrogram, and again we have a problem. Which linkage are we going to use? So you can try to do a single linkage, and then for the single linkage, and take a look on the result and tell me if that makes sense to you or not. And then do another one, do a centroid. So centroid is another type of the linkage not supported in scikit-learn but supported in scipy. Okay, so go ahead and try to do another linkage called centroid, and then take a look on this dendrogram, and then again tell me, well, is this version of the dendrogram make more sense to you or less sense? Okay, and well, from this part, we can definitely have a lot of the good discussions. So go ahead and then do the coding for this part, and I'm gonna just pause this video for 10 seconds, and then I'm gonna show you my answer keys. Okay. Okay, so this is my solution. So just now we have already assembled a dataset, and then for the labels and for the indexes, they are the names of the countries, right? So we want to do a single linkage, and then we want to create a dendrogram, and this is what I got. So well, for the coding part, that's super easy, and you can just grab my code from the Arbor cells and then make small modifications. But what I really want to highlight is here. If you see the purple cluster, so that purple cluster is a big one, right? So we have Russia, Moldova, Georgia. Well, this is not the state of the Georgia, but a country Georgia. Okay, and then Ukraine, and Austria, Hungary, Ireland, Norway, Estonia, San Marino, Latvia. Okay, Iceland, Sweden, Finland. Okay, so if you see this purple cluster, and what do you see? You may want to bring up the Google map, and what I see is the purple cluster are the countries from the northeast Europe all the way to the northwest Europe, from Russia all the way to Iceland. Well, I doubt this result, to be honest, because well, I understand that, say for example, for Poland and Russia, they may have similar taste, and then I see that, or Poland and Finland, they have the similar taste, I see that. But how about Iceland or Ireland? I don't know. Well, I guess the single linkage doesn't give me the accurate clusters. So why? Why single linkage may give you a weird and yet a large cluster? That is the part I want to highlight. Okay, so well, remember what is single linkage. So if I'm just using 5 samples here, so we are finding the closest 2 samples, and then we link them together into a cluster, right? So the closest 2 samples in this case should be those two of them, and then I link them. Okay, and then how do we extend our clustering and then merge by merging another one? So you can see this one is the second shortest linkage. So we link that one. And then what will happen? We link this one, and then we link this one. Okay, so what's the problem? So let's say this is Russia. Okay, and then this might be Poland. And then we just extend and extend, And the strategy of the single linkage will always allow the new neighbor we just included into a cluster to bring in another one and then bring in another one. And what's the problem? Well, the Ireland could be here. Now we have the problem. So originally we started here. That is the cluster between Russia and Poland, and probably those two countries have kind of the similar taste. Okay, and then when Poland brings another neighbor, and then this neighbor brings another neighbor, and then eventually it may go very far. So if we check the distance between Russia to the most recent sample we brought in, which is Ireland, and you may see the distance between Russia and Ireland is already big enough. So that is a problem with the single linkage. For the single linkage, sometimes you will see there are some really large clusters. And inside of this cluster, if you pick two samples, they can be kind of far away from each other. So that is the problem. Okay, so it seems that for this example, single linkage is not the bad thing I want to do. So I want to do the centroid. For centroid, and remember this is the concept we have done in the k-means. So we are making use of the center of the cluster as a centroid. So we are measuring the distances between the centroids, and using the centroid linkage, we ain't gonna see a very big clusters. So well, it kind of prevent this kind of cases. So if you want to see the purple cluster again, now we see something better. Okay, so we have Sweden, Finland, Poland, Ireland, Norway, Estonia, San Marino, Latvia, and Lithuania. So those are the countries on the north side. On the north side of the Europe, is except San Marino. Well, San Marino is a kind of different one, right? San Marino is very close to Latvia and Lithuania. I don't understand that. Well, if you don't know the country San Marino, and you may want to do a Google search, and I really don't understand why San Marino is that close. Considering the taste of the audience and to Latvia and Lithuania. So well, I don't know why, but my observation is, well, this purple cluster now it consists of the countries from the north side of the Europe. So this may make a little bit more sense to me. Okay, and well, of course, there are a lot of the different things, and they are, they are interesting to look at. For example, for the Belgium and the Netherlands, and they are very close to each other. Does that make sense to you? So if you don't know where those two countries are, you can bring up the Google map, and I believe they are very close to each other. So I may say it makes sense that they are kind of close to each other. Okay, so and another question is, how do you want this to be clustered? And we cannot cluster those countries beautifully, and that's my observation, right? So for example, like Malta, and Malta is far away from all the other countries. Okay, so in this case, probably having 10 or 15 clusters, that's not our goal. However, we can highlight some of the clusters. So for example, if we make it cut at 15, for example, and then we have this orange cluster. So this orange cluster kind of makes sense to me. And then for the purple cluster definitely makes sense to me. Okay, so in this case, probably clustering the countries into a fixed number of the clusters is not the biggest goal. However, by doing this kind of visualization, we can visually explore what this data set really look like. Okay, so I guess that's it for today. And here's a quick sum up. For the hierarchical clustering, that is one of the slowest clustering algorithm. So, well, if you have a large data set, you don't want to try hierarchical clustering. However, well, if you have a small cluster and then making use of the dendrogram, and you can make cool visualizations, and then you can also have some sense of the data set, and that is a very useful tool. Okay, so that's it for today, and tomorrow we will have our final lecture for this course. Okay, I will see you tomorrow. Bye.